Today we're on Unit 9, Lesson 1, Linear Regression and Predictions. We'll be covering pages 248 and 249. You want to have your calculator, please. A graph used to determine whether there's a relationship between paired data is called a scatter plot. You had practice with this in Algebra 1. Here we have a scatter plot. The data is closely clustered together and almost in the form of a straight line. So this is a linear regression, and since the data is very closely clustered together, it would have what's called a correlation coefficient close to +1. Here we have another set of data graphed for us, and this is definitely a linear, but it's going downward. It's a downward slope, so it would have a correlation coefficient that is a negative value. Recall how to view scatter plots and write an equation of a line or curve of best fit using the calculator. Steps are outlined here. Step 2 and 3, this is when you want to view a scatter plot. And we'll be viewing scatter plots in Lesson 2. The number that is used to measure the strength and direction of a linear relationship is called the correlation coefficient, denoted by lowercase r. We'll be working with that today. R is between -1 and +1 inclusive. So we have to have diagnostic on, and the calculator will compute the correlation coefficient. And diagnostic on, if you go to mode, there's two ways of getting it. I think the easiest is mode with the newer calculators. And if you see down here, it's stat diagnostics is off. So I'll arrow over, press enter, and now it's on. Linear correlation coefficient close to 0 signifies no significant linear correlation, while correlation coefficient close to +1 or -1 indicates that the points in the scatter plot are close to the calculated line of best fit. So our first linear regression example. We have Emma recently purchased a car. She decided to keep track of how many gallons of gas she used on 5 of her business trips. Results are shown in the table. Write a linear regression function, g of m, for these data where miles driven, m, is the input. So miles driven, m, is the input. And that means that the number of gallons used is our output. This is g, gallons used. So to write our linear regression function, following the steps here, all right, we key the two sets of data in L1 and L2. So press stat, edit, right, following this stat, edit. In L1 goes the input, our miles driven, 150. 50, 200, 400, 600, 1000, arrow over. And then L2, gallons used. So this was L1, this was L2. Everything looks good. Diagnostics is on already. We want a linear regression. So now we press stat. I'm on step 5 above here. Okay. Skipping 2 and 3. Stat, arrow over to calculate. And linear is number 4. Press enter and just enter through this. So this is our A value, and we want to round to the nearest hundredth. Okay. We want G of M is equal to 0.05 M minus 0.92. So that is our equation. B, state the value of the correlation coefficient R, right, to the nearest thousandths, tenths, hundredths, thousandths, so 3 decimal places. R equals 0.999, very close to 1. How many gallons would be used if 225 miles are driven? So we take our equation here from A and substitute 225 in for M. .05 times 225 minus 0.92. It's 13.33 gallons. Oh, 10.33. D, how far could Emma drive on her full tank of gas if her tank holds 16 gallons? So 16 replaces G of M. 16 equals 0.05 M minus 0.92. And let's solve this for M. So we would add 0.92 to both sides. Not that you have to show this. And division undoes the multiplication. 16.92 divided by 0.05, 338.4. So M would equal 338.4, that's miles. So in that example, we found the function value using an input of M equals 225 between given input values of 158 and 1,000, which is called interpolation because the value of M was between our given values, between 150 and 1,000. If we were to go outside of what was given to us, that is called extrapolation. The process of using given data values to approximate values outside the given range of values is called extrapolation. Our next example, we have a table below shows the attendance at a museum in a select years from 2007 to 2013. State the linear regression function, A of t, represented by the data table when t equals 7 is used to represent 2007. Okay, so t equals 7, 7 represents 2007, then 8, 9, 11, 13. Round all values to the nearest hundredth. Let's start there. So we do stat, edit. Now, if I go up to L2 and press clear and enter, it will clear out the data in list 2. And I'll arrow over and up to L1, press clear and enter, clears out the data in L1. So L1 is the year, L2 is the attendance in this case. triple check that I didn't miskey something. I think it looks good. Now we press Stat, Calc, and we want linear regression, which is number 4. And just enter through that. So y equals ax plus b. A to the nearest 100th is 0.16. And b is 7.17. Using the notation we're asked for, a of t. So a of t equals 0.16t plus 7.17. B, state the correlation coefficient to nearest 100th. Right, here's our R value, 0.97. C, determine whether the data suggests a strong or weak association. 0.97 is strong, it's close to 1. D, what does the model predict the attendance to be in 2019? Let's see, 2019 would be a t-value of 16. No. Oh, 2019 would be a t-value of, I gotta add 6 to that, sorry, would be 2000. Alright. We'll put 19 in there. So, A of 19 equals 0.16 times 19 plus 7.17, sorry. It's 10.21. This is in millions. What year would the attendance be? 10.1 million? So 10.1 equals 0.16 t plus 7.17. We'll subtract the 7.17. We have 2.93 equals 0.16 t and divide by 0.16. So 18.3125, which was approximately 2018. In our last example, write a linear regression function f of t for the following scatter plot, rounding to the nearest 100th. All right, so we have this data here in the scatter plot, and this is the 0.11, 12, 22, 23, and so on. All right. So what we need to do is all our x coordinates go in L1. So L1 is our x coordinates and L2 is our y coordinates. And just make sure you have to put them in so that they correspond with each other. So I'm thinking, okay, I've got 1, 1, then 1, 2, then 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 6, 5, 4, and 5, 5. Check that. 5, 4, 5, 5. 6, 6, 6, 7. And 7, 7, 7, 8. Stat, edit, clear that out. Clear out L1. Okay. Looks good. And stat calc number 4, linear regression. And we're rounding to the nearest hundredths. Y equals 0.96, x plus b is 0.57. And using the notation here, f of t equals 0.96t plus 0.57. And it has an R value of 0.93. Thank you for your attention.